During this week, this is the third week, we'll be discussing at length the static inventory problem under risk. Now, during the 5 lecture sessions, the topics which I would like to cover are as follows. In the first lecture, that means at this point in time, I will be lecturing on the general characteristics of the problem, inventory problem, obviously. So you must be aware of what are the typical characteristics a problem may have. You should be aware of. That is the starting point. The types of problems. The types of problems already in the very first week we have come to know that what are the factors affecting an inventory problem, and we have a classification scheme for the inventory problems. So we'll be referring to the types of problems, okay, and each and every type of problem we'll take up and we'll try to formulate the problem, and then we'll propose the solution steps, and then obviously the approach or the solution steps we'll explain with respect to numerical the data or the numerical exercises. So types of problems, one important issue to be discussed, that is the payoff or the outcome. I have mentioned for type 1 problem, but essentially for any type of problem, this payoff or the outcome you should be aware of. So later on when you take up the formulation of the problem as well as the numerical exercise, this point will be made very clear to you. The next lecture will be concentrating on type 1 problem, formulation and solution. In detail we'll discuss, and we'll also refer to one particular aspect called benefit analysis. Okay, so this is benefit analysis we'll do. During third lecture session, again we'll be referring to type 1 problem. Cost analysis will be dealing with, and a few numerical examples we'll discuss. During lecture 4, type 2 and type 3 problems. Essentially what you will find here, that means when you refer to the static inventory problem under risk, the problem can be of say the 4 types. The first problem you don't need to refer to, you don't need to consider. I will tell you what is the reason, but the remaining 3 problems you need to consider. So all these 3 problems are to be formulated, and their solutions, the steps must be known. So during lectures, 4th lecture session, type 2 and type 3 problems will be dealing with the numerical examples, and the concept of opportunity cost matrix for the type 1 problems will be discussing at length. And during lecture 5 session, mathematical formulation for continuous demand distribution. That means mathematical formulation of the inventory problem under this category, static inventory problem under risk. But what we will assume that the demand distribution is a continuous type. Okay, so continuous demand distribution is a very specific case. So we will be dealing with this case along with the numerical exercises. So this is our the plan for this week, and let us first talk about the 3 important issues one by one. First one is the general characteristics of the problem, then the types of the problem we'll discuss, and the payoff or the outcome matrix or outcome the determination for type 1 problem we'll be dealing with. Okay. Now here let me just tell you that we are referring to at this point in time static inventory problem. If you refer to our the week 1 the lecture sessions, you'll find that is the most simple classification of inventory problems. We refer to first the static inventory problem, and then the dynamic inventory problem comes. What is the static inventory problem? That means just it's a one-time occurrence of demand, and as it is one-time occurrence of demand, you can have logically just one order. So the one order is sufficient to meet the demand of say one-time occurrence for a given item. So that is basically the static case. Whereas there are items particularly for the running production system, those items you need to say the procure on a regular basis. It's continuing, the production is continuing, and so also the requirement of a particular item. So that particular item is to be procured on a regular basis. That means one order for a specific time period. The next time period, okay, you need another order. So and this process continues. So this is essentially a dynamic situation. So that's why it is referred to as the dynamic inventory problem. Next, as we have already mentioned, that now we refer to the demand. So the demand may be known with certainty, or the known with risk, or known with uncertainty. Is it okay? Now for the static inventory problem, under say if the demand is known with certainty, obviously the decision variables are known, and everything is known. So you don't need to formulate the problem, you never search for the solution. So that's why the static inventory problem under say the certainty, that means the order will be known, one order quantity also will be known, and so obviously you know everything. Only when you deal with multiple items, and so then possibly you can it is definitely not it is not coming under the inventory control problem. But if you deal with say the multiple items, it may be a problem related to the scheduling. Okay, so we will not be discussing, obviously we don't need to discuss static inventory problem under certainty. This point we have already emphasized. And the demand for the item exists for a specific time period, say 1 week or 1 month or even 1 day or even for few hours. Exact demand is not known. That's why it is called means the demand is known with risk. What is known is demand distribution. This point already we have highlighted during our say the lecture sessions in week 1. So demand distribution is known either in empirical or in standard form. Okay, empirical means is a table form is given. Essentially the possible demand levels and corresponding the probabilities. Is it okay? So these values are given. So these are referred to as the empirical form, whereas it could be in a standard form, like the demand may be Poisson, or the demand may be normal, etc., etc. There may be several examples of such a problems you come across, so that you need to find out. So when we propose the assignments, so you may be asked to so identify a case which falls into this particular category. Okay, so that the during the assignment the sessions you will come to know. So typical examples, 2 examples I am giving you. One is a newspaper is sold for few hours in a day and its demand is probabilistic. Is it okay? So sometimes this problem is referred to as the newsboy problem. Okay. Similarly, a Christmas tree is sold for a period of say 2 weeks in the month of December, and its demand is probabilistic. That's why this problem is also referred to as the Christmas tree problem. Okay, so I repeat, the problem is referred to as in many texts as the newsboy problem or news vendor problem or newsboy problem or the Christmas tree problem. Okay, items needed, this point is to be noted, items needed for seasonal, religious and cultural events are modeled as static inventory problem under risk. Is it okay? This problem, also known as the single order quantity problem, right? If you go through the texts, if you go through the case studies, many a time this is referred to as the single order quantity problem. Now this problem can be classified according to demand. That means there are two important the factors. The first factor determining the problem or the type of problem, determining the problem. First one is the demand. So the demand could be constant demand, you may assume, so CD, or the demand could be variable demand, the notation is VD. And the second important factor, that is the lead time or the lag time, either it may be assumed to be constant CLT, constant lead time, or it may be assumed to be a variable lead time VLT. Okay. So the problem classification is shown in the following figure. Okay, so just look at this figure. Is very clearly we have drawn this diagram. So what you find here, there is a single order model, single order. Just one order is sufficient to meet the demand. Then it could be the outside supply or it could be the inside supply. As you know that if you refer to the original or the classification of problems, this diagram made for say multiple orders also, the dynamic situation. So here it is a static situation, single order, outside supply, inside supply. Now if it is outside supply, there could be a constant demand or variable demand. You need to explore all sorts of possibilities. And then if against constant demand, there could be constant lead time or the variable lead time. Similarly, against variable demand, there could be constant lead time or the variable lead time. Okay. If it is an inside supply case, later on we'll determine both the cases. So while you determine the order quantity and the important so the inventory control the parameters in a given system or a given system. So both outside supply case as well as the inside supply case you need to consider. So that means you need to determine the order quantity, or sometimes this is referred to as the production quantity. So if it is production quantity, is inside supply. If it is an order quantity, it is an outside supply. For outside supply, what you try to do, you place a purchase order. Okay. Whereas for the inside supply, that means from one say the production unit to another unit. Okay. So suppose you need this item in the machine shop, and this item is to be fabricated, right? And then you need to place a work order to the fabrication shop. So that is the inside supply. So this is inside supply, and obviously you don't place the purchase order, you place the work order. Is it okay? Similarly, if it is an inside supply, there could be constant demand or variable demand. Against constant demand, there could be constant lead time or the variable lead time. And similarly, against variable demand, there could be constant lead time or the variable lead time. So if you look at this diagram, what you find that we have explored all sorts of possibilities. That means you follow a particular path, you get one type of problem. You change this path, all possible paths you have, 1, 2, 3, 4, 5, 6, 7, 8. So 8 possible paths you have. That means 8 types of problems you might face. That means for each path you need to formulate a problem. You need to go for formulation, and then depending on say the type of formulation, okay, or the characteristics of the formulation, you search for the solutions or the solution steps. Okay, so you may find that when you consider consider both demand and lead time as a variable one, that may be treated as a most complex problem. Is it okay? Whereas when you consider both the other extreme, when both the demand as well as the lead time, when considered both as a constant, so it may be treated as a simple problem. So always you will find, if you look at a particular path and looking at particular path, you can get an idea about the complexity of the problem. Okay, so the 4 types of problems may exist: constant demand and constant lead time. I have already pointed out. No need to consider this problem for a single item case. Okay, so here we are referring to single item case. There could be an extension of single item case to the multiple item case. Right now we are not discussing that. Okay, so if you refer to multi-item case, and for each item you have this condition, constant demand and constant lead time, then it is a problem related to the scheduling but not related to inventory control. Okay. Next problem is that variable demand, constant lead time. So this problem will be taking up. Variable lead time, constant demand. Is it okay? So this problem also you come across, and you have to formulate this problem. And of course the fourth one, that is the variable demand and variable lead time. It's a complex problem definitely. So we'll be dealing with this problem also. Okay. So these problems need to be formulated and solved. These points I have mentioned. Now let us talk about the type 1 problem. Okay. So what is the type 1 problem? That is the variable demand and constant lead time. So let us discuss this problem in detail. And while you discuss this problem, you come to know actually the basics of so the static inventory problem under risk. Okay. So here, whenever you say that the problem is under risk, that means the probability distribution of demand is known. Okay. Now this demand, that means there is a random random variable. Okay. And so obviously this demand could be a discrete random variable, or it could be a continuous random variable. So the probability distribution that you search for, it may be a standard one. If it is suppose it's a discrete random variable, obviously under discrete random variable, normally if you refer to the textbook, if you refer to the case studies, you will find 3 or 4 types of standard probability distribution you may assume for the demand depending on the situation. Obviously we are assuming that the physical basis behind say selecting a particular say the standard or the distribution, the physical basis is known, and based on so you have a physical basis, and then only you search for or you assume a standard distribution under given level of significance. So here the probability distribution demand is known. So these details we'll discuss later on, but right now just you keep in mind. Okay. So probability distribution of demand is known. Now just I'll give you one one exercise that you start thinking of, that how many ways or which method you follow to specify the probability distribution of demand. Okay. for a given item. So what sort of data you need to collect? Order quantity of the given inventory items, okay, needs to be determined. This is your decision variable, okay, assuming lead time is constant or not. So this is your problem. Now what do you try to do? If certain notations you have to use. So what is the first notation? That means Q is a single order quantity in units. Is it okay? That means here what we are assuming, if you say in units, okay, and suppose it's a discrete units, okay, so obviously it is a discrete, say, random variable, okay, or say not random variable, it's a discrete order quantity, whereas the demand in units, a discrete random variable I have already mentioned, because this order quantity is discrete variable, okay. Now what is PM? PM is the probability of demand of m units. Actually it is probability mass function, PMF. For discrete random variable, the corresponding probability of a given the value is known as the probability mass function. So that is given as PM, okay. So these notations we have used. What is M max? That means the maximum demand in units. Is it okay? It's a discrete case. Suppose the maximum demand is 50 units. So that value you must be able to specify. Now here as you come to know that okay, so as you come to know that there are two sorts of situations. One is against a particular demand, the demand is not known with certainty. There is but the demand is known with risk. That means the probability distribution of demand is known. So the probability that M, that means the demand, is less than or equals to Q, that means the order quantity, is given by these notations you need to use. The probability that M is less than or equals to Q. So how do you specify this? Later on when we formulate the problem, so you just go through all these the notations, the way we are representing these probability expressions, okay. So you please follow these notations, and these are basically the concept you must have while you formulate the problem. So that means this is M equals to 0 to Q. That means the demand could be 0 and demand could be up to Q, okay. So that means less than equals to Q. It's clear? That means it will never, the actual demand will never cross or will be more than Q. That's why up to Q probability that there is a demand for M units, PM. So this is 1 minus M, that means the demand, Q plus 1, more than Q, to M max, maximum value is a discrete case, PM. Is it okay? So obviously what you find that the sigma M equals to 0 to M max PM, obviously it will be 1, right. Probability that M is greater than Q is given by probability M is greater than Q. That means this part basically. That means M equals to Q plus 1 to M max PM equals to 1 minus M equals to 0 to Q PM. Okay, so this is the standard notations of the expressions for the probability we will be using later on. Now when you deal with this particular problem, I will be just adding few important the points related to this particular problem. The decision variable is the order quantity, and when you decide this order quantity, what you are assuming that there is a time period for which the demand occurs. During this time period the demand occurs, say 1 week or 1 hour and all, and the order quantity is sufficient to meet the demand during a specified time period. This is the core issue. So the decision variable is order quantity. There may be a number of possible order quantities referred to as ordering strategies. That means what we are saying, the first you look at the problem and you just try to find out that what are the possible demand levels. Suppose this is a discrete case, right? For a given item, the item is so the number of say certain items, and their demand is known. Suppose the demand for 1 unit, demand for 2 unit, demand up to say 10 units. So you have 10 possible demand levels. So 1 to 10. For now you collect data, parse data, analyze the data, and you say that against the demand 1, the probability is 0.05. Against demand of 2 units, the probability is 0.15, like this. And similarly, against say the demand of say the 10, the probability is 0.05. Is it okay? So what you must have, that is the precondition, that is you must have the frequency data. That means your preference should be that these probabilities must be objective probabilities. In many cases, suppose it's a new situation and since the past data are insufficient, so you cannot get the objective probabilities, but you have to solve the problem. You know it is a probabilistic demand. Okay, so what you need to do, you might get the expert opinion, and then from the expert's opinion, analyzing expert's opinion, you can have also the probability values against a particular demand level. But in those cases, these probabilities are essentially the subjective probabilities. So in many cases, what you find that you start with the subjective probabilities when the past data are insufficient, and as you proceed, that means as you get the data, so in course of time, maybe after a few months, maybe after 1 year or 2 years, now you have the sufficient data. So that means the subjective probability can be replaced with the objective probability. So this is the point to be noted. So whenever you will be using the probability values, we may not be explicitly telling you whether it is objective probability or the subjective probabilities. Okay. So when you discuss the probability aspects, so these two issues must be discussed in detail. That means what is the basis of determining the probabilities must be known. Now, so suppose you have 10 possible demand levels. Obviously, you must have the 10 possibles, the ordering strategies. Is it okay? So the ordering count could be 1, 2, 3, 4, up to 10. Against each ordering strategy, all possible demand levels need to be considered with their probabilities of occurrence. Is it okay? So that is, suppose there are 10 levels of the demand. That means, and suppose your one possible order quantity is 1. That means when you place an order quantity of 1, then against the order quantity there could be the demand of 1, or the demand could be 2, demand could be 3, like this. Is it okay? It may continue up to demand. So up to demand of 10. So against each ordering strategy, all possible demand levels need to be considered with their probabilities of occurrence. Is it okay? So the first condition is the probabilities of occurrence of the demand levels. Against the demand levels, you determine or you identify the possible demand strategies, so order strategies. Once the number of ordering strategies and the number of possible demand levels are known, we need to determine the expected payoff either in terms of profit or cost for each of the ordering strategies. Is it okay? For computation of expected payoff, we need to know the payoff for each combination of order quantity and demand levels. That means suppose your order quantity is 1 and the demand level is 1 with a probability say 0.05. So what is your expected payoff? Similarly, suppose your ordering quantity is 3, your demand is say 5. So in these conditions 3-5 combinations, what is the expected payoff? So you will have, say suppose you have 10 possible demand levels, 10 possible ordering strategies. So how many the combinations you will have? It will be 10 into 10, that means 100 combinations you will have. And for each combinations you have to calculate what is the expected payoff, that means what's the return you get. And then what you do, against each ordering quantity or ordering strategies, considering all the possible demand levels and their probabilities, you need to determine the expected payoff. So if you have say 10 possible order strategies, so you will have 10 expected payoff values, and out of these 10 expected payoff values, which one you will select? Now here one point you must keep in mind, that is this payoff which you calculate, the payoff can be either in terms of the profit or in terms of the cost. If it is in terms of the profit, or more specifically contribution to profit, you just note this point, that actually sometimes we say it's the profit, but truly speaking it is contribution to profit. So if it is in terms of contribution to profit, you select that particular ordering strategies for which the expected payoff is maximum. Whereas if the payoff matrix is created in terms of the cost only, so you select that particular ordering strategy for which the expected payoff is minimum. Okay, so I conclude these sessions. In the next sessions, the other aspects of the static inventory problems we are going to discuss. Thank you.